Lab 10. Amanda Acosta, Alyssa Rodriguez, Alyssa Olguin, Montserrat Nunez.
In this lab, we studied how light behaves when it hits different surfaces. We observed incident and reflected angles using plane, concave, and convex mirrors to understand the law of reflection. We also applied Snell's law to measure how light bends when passing through acrylic and used this to calculate its refractive index. The goal was to compare our experimental values to theoretical values and analyze any percent error.
Auxiliary page, a printed worksheet for tracing the different incidents from the laser. Ray box/light source. Produced a narrow beam of light used to trace the incident, reflected, and refracted rays during the experiment. Reflective surface. The reflective source with different sides, which were convex, concave, and plane sides. The light box reflected the lasers from the box.
In this lab, we used a laser box and a three-way mirror to study how light behaves when it reflects and refracts. We traced light rays on the plane, concave, and convex side of the mirror, drawing the normal line each time. Then we measured the angles between the normal and both the line of the incident and reflected rays for several trials. After collecting our data, we calculated the percent difference between each pair of angles to estimate our measurement error. Next, using the acrylic prism to observe refraction, we measured the angle of incidence in the air and the angle of refraction inside the prism. Using Snell's law, we calculated the refractive index inside the acrylic. We repeated this process with different angles and averaged our results to improve accuracy, then compared our value to the accepted refractive index.
Table 1. Measurements of the incident and reflected angles. In this table, our group records the incident and reflected angles we found for the plane, concave, and convex surfaces. For plane 1, incident angle 1 was 22 degrees and reflected angle 1 was 22 degrees. Angle 2's incident angle was 50 degrees while the reflected angle was 51 degrees, and angle 3's incident angle was 43 degrees and reflected angle was 42 degrees. For concave, the incident angle for angle 1 was 19 degrees and the reflected angle was 15 degrees. The incident angle for angle 2 was 21 degrees and the reflected angle was 20 degrees. For angle 3, the incident angle was 18 degrees and the reflected angle was 17 degrees. Finally, for concave, the angle 1 incident angle was 23 degrees while the reflected angle was 19 degrees. Angle 2's incident angle was 22 degrees while its reflected angle was 20 degrees. Angle 3's incident angle was 18 degrees and the reflected angle was 20 degrees. Table 2. Percent differences between the incident and reflected angles. In this table, our group documents the percent differences between each pair of angles and the average of all the differences. The plane average for angle 1 was 0%, angle 2 was 1.98%, and angle 3 was 2.35%. For concave, the angle 1 distance was 23.52%, angle 2 was 4.87%, and angle 3 was 5.71%. The convex average for angle 1 was 21.05%, angle 2 was 10%, and angle 3 was 10.53%. The average of differences was found to be 8.89%. Table 3. First attempt to find the refraction index of the acrylic. In this table, our group documented the first angle's incident and refracted angle along with the sine of each angle. The incident angle was 33 degrees and the sine of the angle was 0.54. The refracted angle was 54 degrees and the sine of the angle was 0.81. Table 4, second attempt to find the refraction index of the acrylic. In this table, our group documented the second angle's incident and refracted angle, as well as the respective sine of each angle. The incident angle was 25 degrees, while the sine of the angle was 0.42. The refracted angle was 40 degrees, while the sine of the angle was 0.64. Table 5, refraction index of the acrylic. In this table, using the values found in Table 3 and 4, our group averaged our two refraction indexes. Our first attempt had a refraction index of 1.50. Our second attempt had a refraction index of 1.52, and our overall average was 1.51. Table 6, percent error. In this table, our group identified the refraction index for acrylic and found that it had a theoretical value of 1.49. Our experimental refraction index was 1.51, giving us a percent error of 1.32%. Conclusion. After conducting this lab, our group was able to learn about incident and reflective angles, as well as apply Snell's law to calculate the refractive index of the acrylic prism. When comparing our data, our group found that our percent error was greater with our first measurements than it was with our refraction index measurements. Because our percent error was greater than 5%, it can be considered statistically significant. We think a small portion of our percent error for refraction index is due to measurement problems because we did have some difficulty when measuring. However, because our percent error for refraction index was fairly small, we conclude that our measurement error was not significant since we achieved an experimental value that was close to our theoretical value. Some other sources that could contribute to our percent error could be accidentally taking our measurements at slightly different points due to us not seeing the measured angles correctly, thus decreasing measurement accuracy. Overall, measuring various incident and reflective angles during the lab allowed us to observe angle differences based on the shape the laser was directed at. Furthermore, using Snell's law, we were able to compare our experimental values to the theoretical value found from using the equation and compute percent error when comparing values. Credits: Introduction, Amanda Acosta. Materials, Montserrat Nunez. Procedure, Alyssa Olguin. Data, Alyssa Rodriguez. Conclusion, Alyssa Rodriguez. Credits, Alyssa Rodriguez. Thank you.